This is one frame of a movie rendering 8 hours in, not done. Computers were supposed to fix this. Somebody flew to Iceland and stood behind this waterfall. They filmed the blade for a shoot that does not exist yet. A dragon comes out of the water 4 seconds long. 96 frames. There are exactly 3 machines that can compute those frames. And the price of one frame ranges over 4 orders of magnitude. So let's buy the same frame 3 times. 1995 Toy Story, every frame of it was computed by a machine that never simulated a single ray of light. The renderer chopped the geometry into a speck smaller than a pixel. For each speck, it looked up a color and a shininess. Then painted on a highlight that looked about right. Then it pasted on a shadow map worked out in advance. It never asked where the light actually came from. It was told what the answers should look like. 7 hours a frame, 800,000 machines hours for the film on 117 workstations running at 100 MHz. Everything you just heard, I read off a phone. I was running Teleflow, the sponsor of this video, a teleprompter that films you while you read. Manual shutter speed and exposure, so the picture is yours. Scripts sync over iCloud, and any computer on your Wi-Fi drives it from a browser, so your agent can write the script and push it to the phone. And the watch on your wrist is the scroll wheel. Teleflow, the link is in the description and the comment. 18 years later, Pixar threw all of that away. Monster University fires millions of rays out of the camera instead. Each one bounces around the scene until it finds a light or gives up. Nobody paints the highlight anymore. The highlight is just what happens. The catch is that a few thousand rays per pixel is a guess. And a guess looks like a grain. To halve the grain, you need 4 times the rays. 29 hours of frame, 100 million processor hours, same studio, same length of film. 4 times the render time per frame on a hardware that had got 100 times faster. And it kept going. Avatar, The Way of Water, 8,000 thread hours for one frame. That is one core running for 11 months to make 1/24 of a second, 3.3 billion thread hours for the whole film. So here is why nothing ever got faster. Per core, computers got about 500 times quicker. Per frame, we started asking for about 500 times more work. Those two numbers cancel. That is the whole trick. Every time the machine got faster, the industry spent it on being less wrong. That cancellation is why this channel exists, so if it clicked, hit subscribe. Now the third machine. No geometry, no lights, no camera. It has never heard of a ray. It is a network that watched an enormous amount of video and learned what video looks like. You hand it noise and a sentence, and it takes the noise back out 30 times over. Which is strange to say out loud because green is what the path tracer spent 29 hours removing. One machine ends at noise, it pays to get rid of. The other one starts it. And here is a part that actually matters, and it is not the speed. A path tracer costs whatever the scene costs. Add water and every ray that touches it splits in two. Put a waterfall around a dragon and you have built the most expensive shot in the film. The renderer is honest. Hard things takes longer, the model is not. Same tensor, same steps, same bill, whether you ask it for a grey wall or a dragon coming out of a waterfall at golden hour. Difficulty stopped being a cost. The money did not disappear though, it moved. Rendering is a marginal cost. You pay it again for every frame forever. Training is a fixed cost. You pay it once upfront in a building full of accelerators. The cheapest credible way to train a commercial grade video model is about 4,000 GPU days. Call it $200,000, the frontier ones are far past that. But you pay it once and it spreads across every clip anybody ever generates. The render farm did not get faster, it just got moved upstream and shared. What a cent does not buy you is an argument. A path tracer is a function, same scene, same seed, same frame every time. You can say, move that light 4 centimeters left, and it moves 4 centimeters. A model is a sample, there is no light in there to move. You cannot ask for 4 centimeters, you can only ask again. So the real unit of cost was never the frame, it is how many times you ask. For a shoot, nobody has pictured yet, this is once. For a storyboard, it can be enormous, which makes the fight everybody is having the wrong fight. Every renderer ever shipped is an approximation that just got cheaper enough. Reyes faked the light because simulating it was unaffordable. Path tracing won the moment the hardware caught up with the honest answer. This is the same move for the third time, a cheaper approximation that is wrong in a new place. The industry has run this play twice already, and both times the cheap one won and then got good. So, is AI about to change movies forever? Not because it draws a better dragon, it does not yet. Because for 30 years, the cost of a picture scaled with how hard the picture was. That is a part that just stopped being true.